Okay, so today we'll be going over infinite series. Okay? So, an infinite series will be, you can do different types of letters, but we say sum n equals 1 to infinity of a sub n, which equals a1 plus a2 plus a3, and then plus dot, dot, dot. That just goes on forever. Okay? But in some infinite series, we don't necessarily want to look at the complete series to actually do an investigation into it. And we're going to talk about several different types of infinite series, but for some infinite series, one thing we might want to do is examine the nth partial sum. Okay? And let's phrase this like this: the sum equals 1 to capital N of a sub n, which equals a1 plus a2 plus dot 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 a sub capital N. Okay? And we'll write this as S sub capital N. Right? And the limit, as capital N tends towards infinity, of S sub capital N equals the sum n equals 1 to infinity of a sub n. Okay. Now, what type of infinite series would we have to consider some type of nth partial sum and take the limit as n tends towards infinity? Well, there's a very special type of infinite series that you have to incorporate this type of nth partial sum business. Okay? And so the main place that the nth partial sums end up popping up, okay, this is going to be telescoping series. Okay, so let's say we did the sum, now n equals 1 to infinity of, let's say, 1 divided by n minus 1 divided by n plus 1. All right? And so this would come out to, what is the first one? This first one would be 1 minus 1 half, and then plus, then n equals 2, 1 half minus 1 third, like that. And that's going to go on forever. Okay. But if we look at this infinite series, you see that negative 1 half and the positive 1 half? They would cancel each other out. Okay? So for telescoping series, we are going to look at the nth partial sum of this. Okay? So the telescoping series, actually let me just fold this up. Okay. Now S sub capital N, this would equal 1 minus 1 half, and I'm going to write out a bunch of terms. You don't always have to write out this many terms. 1 half minus 1 third, and then plus, okay, 1 third minus 1 fourth, and then plus dot dot dot, and then plus. And whenever I do this, I always start at the end and work backwards. So 1 divided by capital N plus 1, and 1 divided by capital N, okay, and then plus 1 divided by capital N, and then minus 1 divided by capital N minus 1. Okay, so when describing telescoping series, you're really describing it as like a telescope. It expands outwards and then it ends up contracting in on itself. And so 1/2, -1/2, 1/3, -1/4 will cancel with the next one. -1 over n, 1 over n, 1 over n minus 1 will cancel with something inside of there. And so S sub capital N will equal now 1 minus 1 divided by capital N plus 1. Right? Now we take the limit as n tends towards infinity of S sub capital N, which would equal the limit as n tends towards infinity of 1 minus 1 divided by capital N plus 1. Well, what would that come out to be? That would come out to be just 1. And so that would be the sum of this infinite series